Hello and welcome to an introduction to Ricoh 3D. I hope everyone can hear me clearly. My name is Chris Allport and I head up the UK sales team here at Ricoh. So we have a presentation we would like to share and would welcome your questions throughout. Please also submit your questions via the Q&A function and we'll be pleased to answer as many as we can. If your question is confidential, all contact details are shared at the end of. If you'd like something afterward, feel free to email us and we'll gladly answer your query. The webinar will be recorded and shared with you in the next coming days. So as I mentioned, I'm Chris Allport, the UK Sales Manager for Additive Manufacturing at Ricoh. We are missing your interaction with our customers on site and are conscious that many of you may never have visited us. So we thought we'd take this opportunity to introduce Ricoh 3D and do this by sharing a few of our case studies. Although we're a service bureau, technical expertise, engineering innovation and manufacturing knowledge are central to the service we provide. Presenting today will be Enrico, who is our material specialist, and myself. Just to go through some of the areas we'll be covering. We'll start with the introduction to Ricoh and our 3D business in particular, before moving on to case studies and material information, a bit about some of our technical expertise, and before rounding up with a Q&A. So who are we? So Ricoh 3D is located at our factory base in Telford in the centre of the UK. We have an engineering function with groups supporting our core business operations at our marketplace factory. At Ricoh in Telford, we have our own independent business such as our Inkjet Technology Centre and the Additive Manufacturing Centre of Excellence. At this factory, we have a history of customer-centric and co-creation, developing solutions with customers. Our core business operation is the manufacturing of toner products. Toner is of course a fine powder which synergizes with additive manufacturing and our own powder bed systems. So we're a manufacturer at heart. This is where our specialities lie and where we're geared up for mass production. The technologies we'll be discussing are focused around manufacturing of polymer, end-use and prototype parts. From additive manufacturing point of view, we offer powder bed fusion and FDM technologies with the possibility for our customers to also have access to our internal injection molding capabilities. Having said that, we're also committed to investing in the very latest technologies in order to keep our service offering up to date. So nearly 50% of enterprises say that quality control is their top challenge of using their additive manufacturing. At Ricoh, we are well adapted to cover all areas of quality. With our highly skilled team, using CMM machines, we have the knowledge and understanding for all technical quality controls, being able to deliver tolerance heat maps for further reference. Our average monthly right first time also sits at an amazing 95%. According to Sculpture 2019 3D printing report, more than 50% of companies' time is spent at the drawing board, trying to design parts suitable for the process. At Ricoh, we're able to offer design consultation to ensure your parts are the best they can be and suitable for not only the process, but the specific material required. So I'll also now hand over to Enrico to dive a little deeper into what I've just said and go over the materials and a few case studies we thought you might find interesting.
Thank you very much, Chris, for this introduction, and hi everyone. Sorry, from my side as well. So I will provide you now with an overview of our material offering and also show you some example on how we are helping our customer embracing those benefits of 3D printing in their processes and in their product development. So let's start with the most common material available for the powder bed fusion technologies, which is nylon 12, or in short PA12. This is a material that offers a good balance of mechanical properties and thermal resistance, and we actually offer this material on two different technologies: the multi-jet fusion and the selective laser sintering. So if you are not familiar with 3D printing technology, and in particular powder bed fusion printing technology, the main difference between these two technologies is basically the heat source used to fuse the powder. In the case of laser sintering, as the name says, we use a laser, whereas for multi-jet fusion, the powder is fused using infrared lamp, which makes the process slightly faster. In terms of benefits, the main benefits of the multi-jet fusion technology over the selective laser sintering one is the possibility to achieve parts with a more homogeneous mechanical properties for the different printing direction. And also the parts will have a higher density, and it will be possible to have a better resolution for finer details. On the other end, with the SLS technology, we are able to print parts of bigger size. Roughly, the maximum build size of our machine is around 0.5 meter cube. And the material is also biocompatible. So combined with the ISO 13485 certification that we recently acquired for our production facilities, this material and technology is a very good choice for medical application. So PA12 for the SLS technology is a material that is relatively new for us, as we have included it in our portfolio just at the beginning of October. So if you are attending this webinar, we are extending our beat any quote promotion for this material until the end of November. So basically means if you have a cheaper quote from one of our competitor service bureau, you can send that to us and we will match the price. So you can also experience the quality of the parts we can print with this material on our machine. So in addition to nylon 12 and this very common material, we do also offer some more unique materials for 3D printing. And the first one that I would like to highlight here is polypropylene. So polypropylene is, as you might know, is a commodity material that is widely used for a wide range of application for traditional manufacturing processes. It is used for application across different sectors such as packaging, automotive, industrial application, or medical device. It's a lightweight material and is also characterized by a very good chemical resistance. And although this is a material that is very common for traditional manufacturing, it is still less common for 3D printing. However, at Ricoh, we actually been processing it since 2015. So we have a very good experience, knowledge about how to process it and the possible application we can support. This material is also very flexible and has got a very good fatigue resistance, as you can see in the video on the slide. So these properties allow us to produce functional and durable living hinges, for example, which are much more difficult or even impossible to produce with other 3D printing materials or technology currently available. Also, just to give you some numbers, we have done some fatigue tests on the material, and it is able to withstand up to 1 million cycles during fatigue tests. So it's a material that it's really performant. It's also easy to recycle, so it is also a more sustainable solution compared to nylon 12. And the parts we can print on our machine are also very smooth, so the finish is quite nice, and they are also watertight and airtight up to 10 bar, and without the requirement of any post-processing. The material, for your information, has also been approved for use with drinking water application that are known in the UK as RAS approval, the Water Regulation Advisory Scheme. And thanks to this combination of properties, the material is a very good choice for example, for fluid management products, tubes, liquid container, and we also support automotive and medical application with this material. So, although, as I said, the performance of this material are very, very good, I think there is still, from my perspective, a myth about 3D printing, and 3D printing being a technology that is only useful for prototyping. So I would like now to just give you some example specifically on this material about how 3D printing has actually been used by some of our customers at different stage of the life cycle of a product. So from prototyping, but also application in serial production, and also for aftermarket application. So let's start with an example of prototyping in the automotive sector, such as this one from Toyota, which Toyota actually is using our services to validate a number of exterior components for design, fit, and also functionality. In this specific project, we were able to produce components including a large bumper skirt kit for a Toyota Corolla in just a few days, which has enabled Toyota to dramatically speed up their validation process from several weeks just to a few days, and help them save money compared to a more conventional prototyping process. And also by using a material with properties equivalent to the one of the final components, they were also able to use these components to run several performance and functional tests, including some wind tunnel testing. And as you can see in the video, the part is quite large, and it has been produced in different subsections that we have then glued together. So we have optimized the joining process in-house for larger component like this one, and this enable also our customers to benefit from our continuous improvement methodology and working practices. So another large automotive company that has took advantage of the benefit provided by 3D printing and our polypropylene, and not only for prototyping but also for serial production, is Volkswagen. And actually their plastic component segment was originally using PA12 for their prototyping needs. The issue with that was that although they were able to validate the design with that material, they were not able to functionally test the components parts to the same level of the final components. And again, like for Toyota, the problem was a difference in the mechanical properties between the prototype and the final components. So they did again some tests and realized that the actual properties of our material were really close to the properties of parts produced with the injection molding, which is the final process used for serial production. And they also did realize that the 3D printed parts can also be either welded together or welded with injection molded part using conventional plastic welding processes. And this gave them some additional advantages in terms of efficiencies. And then pushing a little bit further the evaluation of the material performance, they realize they can actually use it not just for prototyping, but also for small series production of customized part like this glove box that is produced for a special vehicle. They produce like police cars or ambulances, where the production volume are not high enough to justify the investment in a tool for injection molding, and there is also a need for part customization. So from a cost and efficiency point of view, 3D printing make perfect sense for Volkswagen for this type of application. As I said, automotive is one of the key sector we are supporting, but another sector where we see a lot of interest for 3D printing is medical. And again, I wanted to present to you here an example of a customer that is now using additive manufacturing for serial production. This particular case study is from a local hospital here in the UK, the Robert Jones and Agnes Hunt Orthopedic Hospital. And their orthotics, just to give you a little bit of background, their orthotics department was having issue for years with patients struggling to fit, adjust, and remove their ankle or foot orthotic that you can see pictured here on the right hand side of the slide. And as you can see, there was a requirement for an additional tool that they had to carry separately that was used to compress and decompress the gas spring, which was really annoying for patients, especially for those with restricted movement. So they came up with a quite clever solution and an improvement on the original device, and they developed a lever hinge mechanism which actually stays on the device and make life a lot easier for the patients. So this new device was originally manufactured through conventional machining and assembly, but after discussing with our team, we have been able to help them redesign the part, and at the same time leveraging some of the benefit of 3D printing by consolidating the ball joint feature and removing actually the need for assembly down the line. So in this case, the polypropylene and 3D printing enabled to create a very cost-effective, lightweight product that is robust, is flexible, and can be fully customized according to the patient needs. And the leverage mechanism that you can see in action in the video on the left hand side have been tested for over 3,000 cycles and has an estimated lifespan of more than 5 years. So this device is now in full production. So we regularly print those kind of components for the hospital. And we're really proud to help make playing our role to help make life easier for the patients using additive manufacturing. But also what this case study demonstrate is also how we have helped the customer starting from the design phase, going through the prototyping stage, and now supporting them for serial production. Another example of the use of our polypropylene material for serial production is this rotary atomizer, which is used in the mining or building industry to spray a fine mist of water for dust suppression or for humidification. And as you can see on the right-hand side of the slide, this component has a very, very complex geometry that will be not possible to produce, or very, very difficult to produce using traditional manufacturing method. And actually that's done on purpose, and the component has actually been designed specifically for additive manufacturing in order to remove the quite expensive tooling cost, and also to bringing the end use product just down to a single piece. And here the polypropylene brings some additional benefit One of them is the material is being lightweight, and also the fact that there is no water absorption, which is important for obviously for an application where the device needs to be in contact with water, and that enables to reduce the weight of the rotating mass by around 50 grams compared to a nylon 12 equivalent, which also expands the life of the device in the end use application. And also we have supported this customer not just by printing part or helping them with design, but we're also able to gather the so-called ROS approval that I mentioned before, which actually ensure that the material complies from a regulatory point of view with the intended application. So we have now seen some application for prototyping and serial production, but 3D printing, although can provide a lot of benefits for this type of application when you require serial production or prototyping very customized part or complex geometry, or if your production volume are quite low and you are not able to justify the cost to go down the route of traditional manufacturing, where you might have cost of setting up the production or tooling cost. Another area where 3D printing is quite useful is for producing spare parts, which actually using 3D printing remove the need to hold a physical stock, or if you have obsolete parts that are no longer available. And in this specific case, we have been involved in a project to produce a drip collector for a coffee machine for Krups, which is a French company, ensuring that the Krups could keep their 10-year repair scheme promises on the coffee machine. And in this case, we help the customer to print those spare parts on demand, and being able with our material and technology to meet the required performance in terms of water tightness and thermal performance of the drip collector, and ultimately enable the customer to reduce storage cost and tooling cost and actually optimize their supply chain. The next material I would like to cover now is very briefly is PA6GB, which is a nylon 6 reinforced with glass beads. This is a material that is an ideal choice for when you have parts that needs to be stable at high temperature and require very good mechanical properties. So this material has a melting temperature around 210 degrees, and thanks to the glass beads included in the formulation, the parts printed with the material have also very good stiffness and very good dimensional stability at high temperature. On top of that, the material has also got a very good resistance to fluids such as fuels, oils, and greases, which make this material an ideal choice for automotive application. Just to give you an example, this is like this radiator tank that we have printed for an automotive OEM like Mahle. So that sort of concludes an overview of the material and some sort of case study application for powder fusion material and technology. Now I just want to give over to Chris, that he will provide you with an overview of our offering in terms of fuse deposition modeling, which is a different 3D printing technology. So over to you, Chris, now.
Thanks, Enrico. Give you a voice break for a minute. So as mentioned before, in addition to powder bed fusion processes, we do also offer the option to print your parts using fused deposition molding, which is FDM. On this technology, we offer a wide range of materials from commodity ones such as ABS or ASA up to high performance materials for demanding applications such as Ultem or PA12 reinforced with carbon fiber. We do also offer the possibility for our customers to choose the best combination of printing parameters so they can optimize their parts in terms of cost, appearance, and mechanical properties, depending on the final application of the parts. So FDM is not only a technology that's popular with our customers, but also used for our internal uses. A nice example of this is a dynamic feeding aid that has been developed by our solutions department, and that is used to keep envelopes flat when printing on this type of media. Thanks to this component, customers were able to increase their productivity by 80%. This component was originally manufactured from CNC'd aluminium and pressed metal parts, combined with standard components which had an assembly by hand. However, the lead time of components was up to 6 weeks. Also, with the average of 1 order per month being received, the minimum order quantity of units was 10, which is a little bit frustrating. In order to streamline the supply and reduce the cost of low volume products, the design was optimized specifically for additive manufacturing by consolidating parts to eliminate the requirements for assembly and additional fixing components. As a result, the product lead time was reduced from weeks to just 1 day. The part can simply be produced on demand and in 9 hours, and we do not have to hold any stock. The price of the solution was also reduced from £470 to just 84, while consolidating 36 parts into just 3. So I've just given you a quick run through that. We'll go over what's hot off the printer, so I'll hand back over to you, Enrico.
Thanks again, Chris. So yeah, as mentioned before, and as you probably know as well, Ricoh is a company that is very much driven by innovation, and we are always working to develop new materials or solutions that we can include in our portfolio, and then ultimately solution and that could help our customer expand the range of application where additive manufacturing can be used. So I just want to give an overview of a couple of innovation we have been working on very recently. The first one is a range of so-called thermoset materials that can be can be processed using the selective laser sintering process. We have developed this material in partnership with an Austrian company called Tiger Coatings, and the innovation here lies in the fact that up to now, all the material available for powder bed fusion technology for 3D printing were thermoplastic. So thermoset are a new sort of class of material, which compared to thermoplastic, this material have the main advantage of remaining in the solid state, high temperature, as they don't actually melt like thermoplastic, as you can see on this video, which is comparing a thermoset material in the middle with 2 thermoplastic material on the sides. And also, as this video demonstrates, thermoset materials can be formulated with flame retardant properties, which is an additional functionality to the material. And when they are exposed to a fire or a source of heat, they have a self-extinguish behavior. There is no polymer melt dropping, and they also generate a very low quantity of smoke. On top of that, the material has also have good mechanical properties, and this property can be easily customized based on the application requirement. And there are also some issues that are typical for thermoplastic. Some thermoplastic material like curling or slightly deformation of the part, which are not happening with this class of material. In term of application, we see this material having a very good fit for application in the transportation industry, such as railway, aerospace, or automotive, especially with the increasing electric cars, for example, and obviously also for electrical applications. So we actually just started to taking orders for parts made with this flame retardant material. So if you are interested and to know more or to order some parts with this material, please feel free to get in touch with Chris of myself. And also for your information, we also have a presentation more specific to this material at Formnext this week. And Formnext is the largest additive manufacturing conference that has just started today and will finish on Thursday. So our talk will be tomorrow, Wednesday, at 11 EM UK time. And another nice and exciting development we have been working on in the last few months is a chemical smoothing process for our polypropylene material. And again, we have worked on that in collaboration with Additive Manufacturing Technologies, which is a UK-based company based in Sheffield. Like for many other 3D printed materials, especially those printed using powder bed fusion technology, one of the main blockers to further enable the use of 3D printing for more application or for the production of end-use parts has always been the visual appearance of the part, which is generally inferior to the injection molded part. And actually, with this development, we're actually addressing that problem, and we are now able to smooth the surface of smooth the part printed with our polypropylene material to an injection molding like quality, as you can see on the picture on this slide. And another great thing of this process is that use green solvent, so it's very, very sustainable. Also, all type of geometries, even the very complex one we can produce with 3D printing, can be smoothed consistently, which with this process, which is again another great feature compared to other technologies such as vibrosmoothing, which is a technology we do offer through our service, but has the limitation to only be able to smooth the outer surface of the parts. Also, the process improves the mechanical properties of the parts. So as you can see on the graph, the elongation of break is significantly improved, up to 4 times the value of unsmoothed part. But other properties like the tensile strength or the tensile modulus are not really affected by the process. So we really think that this is a huge step forward for us and our material, because it opens up new opportunities in terms of potential application. Just think at, for example, medical application where parts that needs to be in contact with the body needs to have a smooth surface to prevent the growth of microorganisms, or just having a smooth surface can dramatically helping in keep those parts cleaned. So we are really excited about this development. So we are moving now from an R&D phase to a more commercial scale. So we are hoping to be able to offer this kind of solution from our service at the beginning of 2021. But if you are interested to know more about this process, there is a white paper that has been published, and you can also get in touch with Chris or myself. We are also able to print some of the parts and get them smoothed to just give you an idea of the kind of finish we can we can achieve with this process. So that's all for me for the presentation. I will hand over to Chris for the final slides and a summary of the presentation. Thanks, everyone.
Many thanks, Enrico. Great stuff there. That covered many applications and challenges faced by our customers. So yeah, finally, we move on to our in-house injection molding capabilities. We've been injection molding since the early 90s, which means we're perfectly placed to advise when projects are better suited or more cost-effective with either AM or injection molding due to high volumes or application requirements. Our state-of-the-art 820-meter squared mold shop already produces over 5 million molds a month, with machines ranging from 25 tons to 650 tons and capacity available at a moment's notice. Rapid time to market, complex part designs, and reduction in production quantities calls for prototypes that can be produced both rapidly and cost effectively. Using standard mold parts, RPL have designed, manufactured a quick change mold, which is capable of housing 3D printed inserts to mold small batches of parts. RPL have incorporated a sliding core to allow more technical parts to be manufactured. A great example of this is a recent customer needed 800 parts a year due to low volumes. Tooling injection molding becomes incredibly price competitive in this instance. The concept was to use standard tooling components, roughed out cores and cavities with basic cooling heating circuits. RPL molding can offer a full molding support, trials, project management, and new production tooling and mass production. So why choose us? We have a wide range of materials spanning from SLS PP to FDM Ultim. We have materials for all requirements from high temperature resistance to stiffness, flexibility to cost. We are well equipped to tackle all challenges thrown our way. Similarly to the materials, we offer a good range of processes, including SLS on our Ricoh AMS machine, MJF HSS, and FDM. With all of the above in mind, we aim to get parts out within 5 to 6 working days. We'd also have the option to post-finished parts, including dyeing, smoothing, joining, and painting. We have a vast knowledge of experience across all industry sectors. With the global outreach of Ricoh, more than 80 years of manufacturing experience, there is not much we haven't faced and overcome. We have also recently launched a new website with live online quoting, allowing customers to see instantly where 3D printing is cost effective for them. The website offers a range of materials and 3D printing technologies mentioned in today's presentation, and a really simple, easy way to use it. Our website also has some useful resources to assist you in the selection of materials and technologies with some of our best practices for design, so please have a look at what we can offer. So thanks, Enrico, and thanks to everyone for listening. So at the start, I mentioned that technical expertise, engineering innovation, and manufacturing knowledge are in our DNA, and what we believe sets us apart. So hopefully this webinar has helped demonstrate that. We're going to move through some of the questions that we've received. So is it possible to weld your PP? So yes, it is possible to bond the PP and to post-build to create larger components, as seen in some of our slides. So we can do this by both CADing in the joints, so either dovetails or tongue and groove, and then we basically just glue it together with a strong adhesive to create some of the larger parts like you saw in the Toyota one.
Yeah, and probably we can add on that like I mentioned before, Volkswagen has tested several welding technology like laser welding or ultrasonic welding, and they also works quite well on our materials. So we don't offer that in-house, but if you have access to those welding technologies, we know that it's working with our material.
Yeah, I've got one here for Enrico, which is probably more directed to you. So with the thermoset material, it's got a higher melting point, and obviously you say it's not susceptible to warping or curling with the SLS process. How is that possible?
Yeah, actually, as I said, the thermoset material, they are not really melting when they are exposed to high temperature. They actually just soften, but they don't lose their shape. And this is basically, to be like a little bit technical, this is basically due to the chemical characteristic of the material. In the case of thermoplastic, what we generally do is using the laser or the infrared lamp to melt the powder, and then we cool down, and the material basically solidify, and you end up with your parts. But during the solidification process, there is a change in the volume of the part, which can lead to the shrinkage or the deformation of the part. And this is actually not happening with thermoset, because in this case we use the laser of the printer to make a chemical reaction, and actually there is no a real transition from solid to liquid and back to solid. So you don't have those change in volume that are typical for thermoplastic, and hence you can sort of avoid to have the reduction in shrink, like the shrinkage and the deformation typical for some of the thermoplastic. I hope it's clear, the answer. Maybe a little bit technical, but
I've got another one here for you as well, Enrico. Do you wash the parts after chemical smoothing on the PP?
Sorry, say it again.
Do you wash the parts after chemical smoothing on the PP?
No, the parts are not really washed. What the material is basically smoothed using this chemical smoothing technology. Then at the end of the process, you can basically remove having any sort of residual solvent from the part by evaporating the solvent. Also, just to give you some confidence that all the solvent is removed, and those parts, there is no harm in using them, no risk. In the white paper, for the white paper, we have done some cytotoxicity test on the smoothed part that has demonstrated that the parts are absolutely fine. There is no issue in terms of cytotoxicity. And I also know that other people have tried to analyze the quantity of solvent remaining on the part, and it's really almost not detectable. So I hope this is answered the question.
Cool. Let's just have a quick flip through, see if we've got any more. So no, I think that's it for us for questions at the moment. So that's all that remains to be said. Thank you very much for your time today. There will also be handouts that are downloadable in the handout section that you can click on. Alternatively, if you would like to email myself, Enrico, or the 3D printing inquiries address, we'll be happy to send you out any information that you require. If there are any other questions that you think of, we'll be more than happy to follow up. If you fire it straight over to our email addresses that you can see. So yeah, that's all that's to be said. Thanks all, and take care.
Thank you everyone. Bye from me as well.